Hello everyone, so today I'm going to explain how the ADAS works and how we design it in Ansys SCADE. So I will start in this video by explaining how the ACC works, which is the Advanced Cruise Control, and which control the speed of the car depending on the free space in front of the car, the free distance. So let's start. We are using Ansys SCADE for this video. So this is our ADAS system, and we can see that it is made of two blocks mainly, the AEBS, Automatic Emergency Braking System, and the ACC. In this video, we are looking at the ACC. So we can see on the left of the ACC operator all the inputs that it needs, and on the right, all of the outputs. So let's review them one by one. The ACC on is a boolean, and it will be used by the button in the car to activate the ACC. So in the car we have a on button, and if the driver push the on button to activate the ACC, this boolean will be set to true. And in the car we have another button which is ACC off to disable it. And this is this input. Another button, resume. So when the driver will press the brakes, it will put the ACC into an interrupt state. So in the car, we have a resume button to go back to the normal functioning ACC. The ACC set is another button to set the speed of the ACC, so the target speed, to the current vehicle speed. The quick accel is another button on the car that increases the target speed of the ACC. The quick decel is the same, but it decreases the current speed. The accel is a percentage that represents how much the accelerator pedal is pushed or pressed. The brake is the same, but for the brake pedal. This one is the clearance, so the free distance in front of the car, because the ACC automatically adapts the target speed with the free distance in front of the car. The speed is the current speed of the vehicle. And the emergency state is actually an output from the braking system, automated emergency braking system, and it lets the ACC know if we are in an emergency state. And in this case, we see that the ACC goes into an interrupt state. And on the right, we have the outputs. So first, the cruise speed, which is the current target speed of the ACC, the speed that the car will try to automatically maintain. The cruise state, which will be displayed to the driver so that he knows that the ACC is active or not, or interrupt or else. And the last one is the throttle command, so that is the power that is sent to the motor. So let's see what's inside this operator. So we can see that we have a lot of state machine. So the first one is the biggest one, and it will be in the off state by default. And if the driver push the ACC on button, it will switch from the off state to the enable state. And in the enable state, we first have this block, this operator. So this operator lets control the target speed of the ACC. So we have the set button that set the cruise speed, the target speed of the ACC, to the current speed of the car. And we have the two quick accel and quick decel button to increase or decrease the speed of the ACC. And in the output, we have the cruise speed and the local cruise speed. So that is the same. the cruise speed is sent as an output of the global ACC operator, and we have to create another local variable that is called local cruise speed to reuse it, to use it again in our operator just here. So that's it. We also have an interrupt condition, so we'll see that in a moment. In the enable state, we have another state machine. So SM2 is a state machine in one of the states of SM1. And what we have in the second state machine, we have two states, the active state and the interrupt state. And we can see here that we can switch from the active state to the interrupt state with the interrupt condition. And so this condition is defined just here. So when do we go from the active to the interrupted? We go from the active to the interrupted state if the brake pedal is pressed, or if the emergency state, which comes from the AEBS, is in emergency braking. So if the emergency braking system has been triggered. And when we go to this interrupt state, we don't do anything. Oops. We don't do anything, but we can go back to the active state if the driver push the resume button. So what do we have in this active state? We have another state machine with two states. So the state on and the state standby. And how do we go from the state on to the state standby? With the standby condition. So what is the standby condition? It is defined just here. So we go to the standby if the accelerator pedal is pressed, or if the speed of the car is not in the limits of what can do the ACC. So we have a minimum and a maximum speed at which the ACC can operate, and if we go beyond, we'll put the ACC in standby. And if none of those conditions are valid, we'll go back to the on state. So what do we have in the on state? We have the cruise control. So this is a block that takes the target speed of the ACC, local cruise speed, the current speed of the car, and the free distance of the vehicle. And with those three inputs, we'll calculate the throttle command, so the power that will send to the motor. So let's see how it works inside. So we have another state machine with two states. One if the clearance in front of the car is normal or safe, and one if the clearance in front of the car is too small and that causes a warning. So let's see how we go from clearance normal to clearance warning. So it is if we have the warning condition, and the warning condition is when the clearance, so the free distance in front of the car, is smaller than the safety distance. The safety distance, we can calculate it from the vehicle speed. So in this case, if the clearance is smaller than the safety distance, we have the warning condition and we will go to the clearance warning. And how do we go back to the clearance normal? That is when we have the normal condition. And the normal condition is when the cruise speed, so the target speed at which we want to go, if the cruise speed is smaller than the safe speed. And what is the safe speed? The safe speed is the maximum speed that we can drive with the current free distance in front of the car. Okay, so next, what is the difference with between clearance normal and clearance warning? We see that we have the same operator inside. Cruise regulation is present in both, but the only difference is that in clearance normal we use the cruise speed as a target, whereas in clearance warning, we use the safe speed. That is because when we are in clearance warning, we can't go to the target speed we have set. We have to go to the safe speed because there is a warning. And the cruise regulation, we calculate from the target speed and the current speed the amount of power we need to send to the motor. And this is made with a PID algorithm. So this is the speed regulator is a proportional integral regulator. So that explains how we design our ACC. And in the next video, I will explain how we made the AEBS. So thank you again for listening, and I hope you like it.